Hello everyone, welcome back to my YouTube channel. I am Yashaswini. I am studying BE in Sri Venkateswara College of Engineering. In this video, I am going to discuss about Anova. Introduction. Analysis of variance is a method for testing the hypothesis that there is no difference between two or more population means. The Anova technique enables us to perform the simultaneous test and as such is considered to be an important tool of analysis in the hands of a researcher. The significance of the difference of means of two samples can be judged through either z-test or t-test. Z-test is applied to find out the degree of reliability of statistics in case of large sample. Z-test is based on normal probability distribution and is used for judging the significance of several statistical measures, particularly mean. T-test is used to test the null hypothesis that the population means of two groups are the same. T-test with two samples is commonly used with small sample size, testing the difference between the samples when the variance of two normal distributions are not known. T-test is also used for judging the significance of the coefficients of simple and practical correlations. When there are more than two means, it is possible to compare each mean with each other mean using t-test. However, conducting multiple t-tests can lead to severe inflation of the type 1 error rate. ANOVA can be used to test difference among several means for significance without increasing the type 1 error rate. The ANOVA technique is important in the context of all those situations where we want to compare more than two populations. In such circumstances, we do not want to consider all possible combinations of two populations at a time, for that would require a greater number of tests before we would be able to arrive at decision. What is ANOVA? ANOVA is a procedure for testing the difference among different groups of data for homogeneity. The essence of ANOVA is the total amount of variation in set of data is broken down into two types: the amount which it can be attributed to chance and that amount which can be attributed to specific cause. Basic principle of ANOVA. The basic principle of ANOVA is to test for difference among the means of population by examining the amount of variation within each of these samples relative to the amount of variations between the samples. Assumptions in ANOVA: the experimental error of data are normally distributed, equal variance between treatments, homogeneity of variance, independence of sample, that is, each sample is randomly selected and independent. ANOVA techniques. One-way ANOVA: it is the simplest type of ANOVA in which only one source of variation or factor is investigated. It is an extension to three or more samples of the t-test procedure for use with two independent samples. In another way, t-test for use with two independent samples is a special case of one-way analysis of variance. Two-way ANOVA. Two-way ANOVA technique is used when the data are classified on the basis of two factors. For example, the agricultural output may be classified on the basis of different varieties of seeds and also on the basis of different varieties of fertilizers used. A statistical test is used to determine the effects of two nominal predictor variables on a continuous outcome variable. Two-way ANOVA test analyzes the effect of the independent variables on the expected outcome along with the relationship to the outcome itself. Two-way design may be repeated measurements of each factor or may not have repeated values. Types of two-way ANOVA. Two-way ANOVA types are ANOVA techniques in context of two-way design when repeated values are not there. ANOVA technique in context of two-way design when repeated values are there. ANOVA technique in context of two-way design When repeated values are not there, it includes calculation of residual or area variation by subtraction. Once we have calculated the sum of square for total variance and for variance between varieties of one treatment, as also for variance between varieties of the other treatment. Anova technique in context of two-way design, when repeated values are there, we can obtain a separate independent measurement of inherent or smallest variation. Interaction variation. Interaction is a measure of interrelationship among two different classifications. Graphical method for studying interaction in two-way design. For graphs, we shall select one of the factors to be used as the x-axis. Then we plot the average for all samples on the graph and connect the average for each variety of other factors by distinct line. If the connecting lines do not cross over each other, then the graph indicates that there is no interaction. But if the lines do cross, they indicate definite interaction or interrelationship between the two factors. Assumptions in Anova: the experimental errors of data are normally distributed, equal variance between treatment, independence of sample, each sample is randomly selected and independent. Thank you for watching my video.